there are certain type of mistakes that I think if you understand what you are doing, you would not do. And unfortunately, I have observed this kind of mistakes happen in the quiz that I have marked recently, hence this video, right? So Bismillah. Among the things that we have to calculate in this course is how to convert or how to express a certain, say, force from a magnitude into Cartesian vector form, right? For example, if you have a force, we know the magnitude, certain amount of Newton or kilonewton, how to express it in terms of Cartesian vector form. So there are certain things that you have to do to get into Cartesian vector form, but there are certain type of mistakes that I don't think that you should do, and we are focusing on that. So basically, when we have a certain force, for example, right, and it is directed in a certain direction in the 3D space, and it has a certain value, let's say 300 Newton, and we need to convert it into Cartesian vector form. So what is F as a Cartesian vector form? So basically, when you calculate, you will have certain thing like this. So something I plus something J plus something K, right? And then you have Newton there. So these values basically you have to calculate. But what are they actually? These are the X component of this force, this is Y component, and this is Z component. I think you understand that. But what exactly are those components? Right? So basically, if you draw, for example, the axis in 3D space, let's say, so Z, I only draw the positive side, so this is X, Y, and Z, right? So when we say component, right, these are the component that basically makes up the full force, right? In this case, force. So let's say the X component is in positive direction, so let's say this is here. Let's say we have Fx there, where this is Fx, for example, right? And let's say Y component is also positive, so let's say this is Fy there. And let's say Z component is also positive, so you have Fz here. So these are the components which will make, let me use a different color then. So if you project this like this, basically, okay, it's outside there. And then you go up. So how to do this? This one, if you go up, and this one, if you go somewhere here, and then up here, right? Of course, if you have the parallel there, something like that. So in the 3D space, basically this is the component, and component, which will give you this force over here, right? That is F, where it have the X component, Y component, and Z component that makes it there. To discuss this, I think it's easier if we just focus on 2D first. If you have a 2D, let me draw here, right? So if I have X and Y, right, this in 2D space, so if we have X component here, Fx, Y component here, Fy, and no Z component going out of the whiteboard, so basically this will be the force, where it will have this X component, Y component, and in this case no Z component, right? So you'll get Fxi plus Fyj plus 0k in this particular case. Now there are several things that you should understand by this, but number one, this value is directly related to this and this, right? You can calculate. So basically what we know is F equal to square root of Fx square plus Fy square, right? So that's number one. Right, number two, the obvious thing about this is because if you redraw this triangle, right? This is Fx, this is Fy, this is F, right? So you can redraw in any quadrant that you want. For example, if Fx is negative, Fy is positive, it will be there. If Fx is negative, Fy is negative, it will be there. But it will always be the same, where F is the hypotenuse and this is the other two side, right? So it becomes bizarre if you have 300 Newton here, when suddenly some of this is bigger than 300, because that is physically impossible, right? So any of this, confirm for sure, will be less than this. Just like any of this will be less than f, right? So it is interesting when I see an answer where you start with the magnitude and then you calculate and then you get the components to express the Cartesian vector form. Suddenly some of the component is bigger than this one. If you understand what's going on, you should understand there and then, okay, some mistake have happened. This is not possible. But if you continue on calculating, it indicates that you don't even know what's going on, right? So that's number one. Number two, you can verify, right? So when you have this value, right? So for example, this is fx, fy, fz. So you can straightaway calculate f should be equal to square root of fx square plus fy square plus fz square, right? So if this, and this takes like 10 seconds if you use your calculator, right? So okay, if once you have already the value, something, something, and something, you just put square root of this square plus this square plus this square equal to, that's like 10 to 15 second maximum. So that checking there should be your habit, just to double check in case any mistake happen, right? Just to double check. And when it's confirmed, alhamdulillah, proceed. You do not waste too much time there. But if it's obviously not the same, right? For example, if you, number one, if anything above this one, for sure you will get something much bigger than the origin value. That's wrong. Number two, if you do this and you do not get back this one, something is wrong as well, right? And most bizarre thing I see in the quiz is that because they want to calculate, I'm not sure, I don't remember, but the student actually recalculate this f using this formula and get something else other than 300, and they continue on. What? Right? So you should know that when you calculate the magnitude of this one, it goes back to here. If you can get something else and it does not alert you that you have made a mistake, something is wrong with your understanding. So I'm not trying to push anything, not to try to push you down, not to call you anything. I'm just saying that please make sure you understand some of these very basic things so that some very obvious mistake, you should, when it happen, hopefully it never happened, but when it happened, you can straightway detect, okay, there's a mistake, recheck, right? So this is related as well to some of the mistake that happen when some student calculate a unit vector. For the sake of not making these videos too long, that will be in the next video, inshallah. Hopefully you get something from this. Inshallah, wallahu alam. See you next time.